Consider the following systems of equations and solve them using a method of substitution. In this question, the steps aren't any different than what we've seen before. We're still going to use substitution. But in looking at the equations, I can see they've added an additional layer of work by not simplifying those equations. So what I'm going to do is I'm going to start with that 5 times 2a minus 3, 2a minus 3 plus b equals 5. And the first thing I'm going to do is FOIL out the brackets there and just write this equation in the most simplest form. So the 5 has to go through the brackets. So 10a minus 15 plus b equals 5. And then just collect like terms. So 10a plus b equals 20. And while I'm here, I might as well isolate one of my variables, and it makes sense to isolate the b, since I wouldn't have to divide anything. So b equals 20 minus 10a. So I've isolated that. Now let's look at the second equation. 6a minus 2 times b minus 4 equals 20. Before I do anything, I just want to get rid of those brackets. So I'm just going to FOIL out there negative 2b. Now it's a negative 2 times a negative 4, that's plus 8 equals 20. So 6a minus 2b equals 12. So when I subtract 8 from both sides, I'm left with 12. Now I'm just going to grab a different color here, and I'll make the substitution. Anywhere I see a b, I'm going to substitute this whole equation in. So 6a minus 2, and there's my whole equation, 20 minus 10a equals 12. I'm just going to have to continue down into the area for part b here. So altogether I have 26a, and I'm going to add the 40 to the other side. So 26a equals 52, which means my a, when I divide both sides by 26, has a value of 2. Now I'm going to take that value back to one of my original equations. You can go right back to the beginning if you want, or you can go to one of these equations, or even there. So any form of the equation as you went. So for me, I'm just going to choose this one here that was already had the b isolated. b equals 20 minus 10 times 2. So b equals 20 minus 20. So in this case, I'm getting a value of 0 for my b. Part B wants us to verify this algebraically, so take those values, substitute them into the equation you originally started with, and see if they work. Now in this case I am going to go right back to the original just in case I made a mistake somewhere. So 5 times 2, and then wherever I see an a, I'm going to write a 2, minus 3, plus b, which is 0, and just check, does that equal 5? So this is going to be 5 times 4 minus 3. Plus 0, or 4 minus 3 is 1, so 5 plus 0 equals 5. Yes, it does. And again, let's verify with that second equation here. So 6 times 2 minus 2 times 0 minus 4, does that equal 20? So 12 minus 2 times negative 4 equals 20. So 12 minus negative 8 equals 20. That's the same as saying 12 plus 8. Yes, so that one checks out as well.